to respond to changes in customer demand, changes in the marketplace, and to respond to threats and opportunities. And so we have to be able to adapt quickly. And that hasn't been the hallmark of IT organizations for quite some time, unfortunately. So what did we used to do? For those of you who have been around long enough, you may recognize some of these things. Remember component-based reuse? How we were going to have these wonderful architecture teams that sat in their nice ivory tower office and figured out how everyone in the entire organization would use these business components, and they would get reused. And some of these unfortunate architects were even rated in their performance evaluation on the number of times their components got reused. Now, unfortunately, because they were so disconnected from what development was actually occurring, it was very difficult for them to figure out how to write these components in such a way that anybody might actually want to use them. Remember integration by databases. This is how we used to do things. You have this great big honking database with all kinds of stuff in it, and everybody has these applications surrounding the data. And of course, the ever popular whipping boy of service-oriented architectures. Service-oriented architectures tried to say they could achieve what it was that we were trying to achieve. Now, come on. SOA did get some things right. And the first thing it really got right was it started to allow organizations to think that everything doesn't have to be a monolith, that you could have things in smaller chunks. It also started people thinking more about you can have integration among these functions rather than coupling. You can think about middleware, you can think about messaging, you can think about more loosely coupled approaches. It encouraged a greater acceptance of this notion of eventual consistency. For a long time, the DBA ruled. Data was this valuable resource, and it was the DBA's job to protect that. And everything was relational, everything was transactional, and every time you said, I need to persist this, it's like, okay, you need to put it in a relational database. And there was no question, and everything had full transaction, all the capabilities of those relational databases. That's how everything was. And SOA at least started the conversation that perhaps there's another way. That we could think about building systems in some way other than the monoliths that we were building in the past. So that's some of the things that SOA got right. Unfortunately, SOA still made a lot of mistakes. And probably the biggest one is the monster services. When you start to look at some of the services that were built under these models, you get these massive services that maybe aren't as big as the entire monolith, but they're still very large, very difficult to change, very difficult to deploy. Come on. And part of the reason for this is they tended to be producer-driven services. And what I mean by that is when you think about, I'm going to write the customer service, and this is the information I'm going to make available to people. As I am the producer of this information, I'm assuming I know how people are going to want to use this. In much the same way the architects back in the component reuse days were trying to figure out how people were going to want to do it. These were all producer-driven. And very often they came from the IT organization as opposed to the business. And they were thinking about things from the context of the systems rather than the applications, the business application. There was a lot of orchestration. And the distinction I want to draw here is the difference between orchestration and choreography. When you think about an orchestra performance, you have a conductor up front, and he's guiding the entire orchestra. He's setting the tempo, he's having the volume changes, all of that. He is in control, and every single person in that orchestra is paying attention to what that conductor is doing. And if for some reason you need two things going on, you have two conductors. There are some symphonies where at times you have two different conductors. Somebody is always in charge. Choreography, on the other hand, think about a dance performance. What a choreographer does is they lay out the vision of what it is that this piece is supposed to achieve. And each individual knows the part that they are supposed to play and how they are supposed to interact with the other players. But in the performance, the choreographer is not out front pointing to people and making sure they're doing the right thing. Each of the individuals knows what they're supposed to be doing, knows how they're supposed to interact. And therefore, if something goes wrong, they have an idea of how they might respond. So that's the difference. SOA was all about orchestration, which gives you a lot of centralization of control, and it's often very difficult to test. The tooling very often got in the way. We had and I think part of what made SOA go so horribly wrong was the fact that we had all of these tool vendors who were convinced that if we just had the right services, we could truly have that vision of the business person sitting in his office with the doodleware, reconfiguring all of their business processes. And that really hasn't arrived yet, but the tooling was trying to make that happen. And so you had tools that were designed for a category of user that were being used by different people. And unfortunately, what we ended up with were things that were even harder to change than they were before, which of course wasn't what we were trying to achieve. These things were also much harder to test. So I'm going to talk about microservices. To some extent, you can think about microservices as SOA done right. We are talking about services. We are talking about an architectural approach that is looking at services as their fundamental unit. SOA stands for Service-Oriented Architecture. So this is maybe SOA 2, but we need a different name. And part of the reason it's called this is we want to focus people's minds on, among other things, let's not produce the monster services. So this is a quote from the article that James Lewis and Martin Fowler wrote describing microservices. And basically what this is saying is we are going to take our single application and we are going to break it down into smaller components, each running in its own process, communicating over a lightweight mechanism, potentially HTTP, but the focus is a lightweight mechanism. Come on. So what are the characteristics of these microservices? Well, the first one is obvious. They're small. Now, what constitutes small? That, of course, varies. But you want to think about these things from the perspective of these things need to be smaller rather than larger. You want to build them around business capabilities. One of the traps that we fall into as we develop things is that we think about things from the perspective of systems, but our users think about that in the concepts from the business. So we need to start to think, rather than systems capabilities and systems boundaries, what are the business capabilities? And we want to start organizing our work around that, because the way our business users are going to conceive of reconfiguring their business processes, it's going to be in the fundamental units of how they think about the business. They don't care how it's implemented. They don't care what the systems look like. They think about this thing from the perspective of the business concepts, and so we should build around those business capabilities. These things are independently deployable, which means you can replace one service without necessarily having to touch another, as long as you don't touch the contract. There is very little centralized management. And part of what this means is that because these things are independently deployable, they're in separate processes, we can start to break the dependence on technology stacks as well. It is easier for us to start thinking about, I'm going to use Clojure over here because of the analytics that I want to do, but I'm going to use a different language over here, maybe because of the strong object model that I need to model my domain concepts. We are no longer tied to technology stacks because these things are independently deployable. We want to have smart endpoints and dumb pipes. Basically, it is easier to reconfigure things if the things on both sides of that pipe are the ones that are enforcing the assumptions, that are doing the validations, rather than having to rejigger what's going on in the pipe when I want to move things around. So smart endpoints and dumb pipes. And a lack of a centralized shared database. One of the things that we start to think about when we're breaking up these monoliths is, what should the data architecture look like? What are the what are the units of data that we want these different services to be effectively the master of? Who is going to be responsible for maintaining information related to a particular business concept? And maybe other applications need some kind of cache of that, but we have a much different view of data architecture. So what are some of the implications of this? Well, first off, the granularity question is crucial. When you try to decide what your service boundary should be, that is probably the single biggest design decision you're going to make in a microservices architecture. And you want to balance having something that is a cohesive whole with the amount of coupling. Now, it's interesting. Internally, we have, at various points in time, conversations about, well, I'm at this place, and they've got a couple hundred services, and I want to merge services together. And another group will be saying, I'm at some place, and we're actually trying to separate our services. That is one of the things that you're going to be doing a lot of, is splitting and merging, particularly until you understand what those boundaries should be. And I'll come back to that point later. These things are independently scalable, which gives you a lot more flexibility in terms of how you're going to deploy. So if I need to scale up one service because of its compute profile, that doesn't mean I have to scale up everything else. Monitoring of this is critical. If you've got a monolith, by definition, you have one thing to look at, or one thing in each data center. When I replace that monolith with multiple services, I need to start looking at how all of those different services are working. Are they all working? Are they all working properly? And so I need a much more sophisticated monitoring regime than I do if I just have a monolith. And we have to design for failures that we don't have to think about when we're in a monolith. We have to think about, okay, well, what is the consequence for this business process, which probably is made up of several independent microservices, if this particular service fails? We have lots of failure scenarios that we just don't have to take into account if we're dealing with a monolith. And because we are deploying lots of different things, and we've got a much more complicated landscape than we have with a monolith, we really want to look at things like infrastructure automation, automated deployment, all of the things that go in with continuous delivery. And of course, the downside of flexibility in your platform is that you can have a proliferation of technologies. There are times when making a different technology choice is the right thing to do because of the increased efficiency it's going to give you in that component. But you don't want to have it get out of control. I was on one project once that at one point we had 11 different XML parsing libraries. 11. Now, there are two fundamental ways to parse XML, so I could kind of understand two. 11 was just people being lazy. And so we do need to have some form of management around this platform so that we don't have every programming language under the sun and every database under the sun, et cetera, just because we can. So we need to keep some level of control over what our platform stacks look like. And then, of course, eventual consistency has to be managed. As soon as we start to distribute data across these different services, we have to start thinking about what does that mean in terms of propagation of information. One consequence of this, of course, is we have to explain to our business users what eventual consistency means. And as Ino pointed out, sometimes they think that it might be just possibly consistent rather than eventually it will get there. So we have to start to think about what are the consequences of some of these state situations that we might get into because of the existence of eventual consistency. And again, if you've got one big honking relational database, you don't have to worry about this. So there's a lot of things on this list that are a whole lot more complicated. We have to think about things that we just don't have to think about if we have a monolith. And so that ought to start you thinking, well, why then would I do it? We want to make sure that we are going to get the benefits from being able to go as fast as possible to justify paying the cost that we're paying up here. This should also tell you that microservices shouldn't just be something you go out and say, I'm going to do microservices now. Isn't that wonderful? I'm going to be one of the cool kids. And of course, finally, interface churn needs to be managed, particularly when you're trying to sort out what those boundaries should be. You might actually have a lot of those contracts that are changing, and we need to think about what that means. And for those of you who saw James's talk, that's going to vary depending on how many boundaries, if you will, these interfaces are going over, how closely the teams are connected. Because it's easy to change the service boundary when the person sitting next to you is the one who's writing the other service. It's much harder if they're half a continent away or half a world away. Okay, so those are some of the implications of making this choice and some of the things that we're going to have to think about and the problems that we're going to have to solve if we go down this microservices path. So, we've got two possibilities. The first is Greenfield. We all love that when we get to develop an application with nothing, no legacy whatsoever. It does still happen occasionally, but it's rare. And one of the things, Martin is going to be putting out a post on this soon, the thing that we're recommending is, in general, don't start developing a Greenfield application using microservices. You probably don't know enough about the domain to even get close on the service boundaries. And so start building it as a monolith. Try to make it modular. Try to make it easy to separate these things. But don't start with microservices until you have a real understanding of where those boundaries ought to be. So generally speaking, you are going to be breaking up a monolith. It might not be a nasty, big ball of mud monolith, but you're probably going to be starting here regardless. And so the first thing is to think about this from the perspective of the bounded context, and this is the notion from Eric Evans' domain-driven design. What is it that you can draw a cohesive circle around that's self-contained and that represents something that makes sense in the business domain? Where are those bounded contexts? And that's going to be one indicator that that's probably going to be a reasonable service boundary for you. So that's the first thing to think about it. And going back to what I was saying earlier, you have to have a fair understanding of your domain to be able to make decisions such as this. We all know how domain models tend to evolve over time as we learn more about the application that we're trying to build. And so what constitutes a bounded context in your mind may actually change as well. So this is the first hint of what a service boundary should look like. Try to think of it from the perspective of domain-driven design and bounded contexts. Again, think about business capabilities. What are the value streams that exist in the organization? What are the products or services that are being delivered by this system? Think about it from that perspective. And that will also guide you in thinking about, okay, what makes sense in terms of drawing a service boundary. Think about what the consumers need. Rather than these producer-driven contracts, try to do a pull. Try to think about this from the perspective of what is the user of this service going to want, and build those contracts. Think of it from the consumer's perspective first, because then you're responding to a real rather than a perceived need. And think about the communication patterns. Which services might be using, or which parts of the system might be using the same data? How might they have to collaborate to achieve a particular business outcome? What do those communication patterns look like? Because one of the things you're going to be balancing is if I split a process across two services, I've got a communication boundary there. And that introduces time, that introduces potential for failures, so I've got to think of all kinds of failures. So think about how those things are going to be communicating when you decide whether or not you want to combine those two into one service or keep them separate. And think about the data architecture. People often don't think about things like, what is the retention policy? What are the protections that are necessary? What are the impacts of things like eventual consistency? How you think about the data and what the proper organization for the data is also something that is going to indicate to you what a sensible service boundary might be, because services own their data. We're no longer thinking about services that are floating around one large database. We've got separate persistence stores for each of these services as well. Think about correlated change patterns. If two parts of the business tend to change together, that is going to be an indication that maybe you want to combine those into one service. So think about the likely changes that are going to happen. Be prepared, though, to get it wrong. Be prepared. You might have to merge services together. You might have to split services back out again. And given the fact that we've got separate data, you might be splitting data. You might have to, if one service is now going to be the master in terms of updating the data, maybe the other service is going to need to cache that data. If you're going to merge them, you're going to have to do the data migration. So again, service boundaries are not something you want to change a lot, because changing those boundaries has significant implications as well. And be a tolerant reader. One of the things that we try to do, and this is one of the connections to evolutionary architecture, we can't make it so that you never have to make a breaking change. That is not possible. But what we can do is ensure that we only have to change when there is no other choice. And tolerant reader is one way of ensuring that the only time you have to change your service is when they're changing something that you need. So when we're looking at this, this will allow those interfaces to change a bit more before we actually have to change our implementation. Okay, so what are some of the other connections to evolutionary architecture? Well, when I talk about evolutionary architecture, there are lots of different principles that I think are critical, and why I think evolutionary architecture is actually so important. And these are some of the principles that microservices exhibit. First and foremost, the whole reason we're talking about microservices is because we want to be able to rapidly change the system. So the focus, the reason we are doing microservices is to allow us to change as rapidly as possible. And evolutionary architecture is all about making evolvability one of those first-class ilities that architects worry about. Not just maintainability, but evolvability. And part of evolvability is not predicting the future. It's being in a position to respond to changes regardless of whether you were smart enough to think about them or not. So often in the past, evolution and reuse was always focused at, I've got to be smart enough to figure out all the different possible ways this could change. And I write all kinds of things for this hypothetical scenario that chances are never comes to pass. And so microservices are focused on evolvability. We want to think about the evolution of the system as a first-class object. Tolerant reader, I already talked about. But obviously, tolerant reader is another way that we make it possible to change things as much as we can, but before we actually have to break something. Exploiting Conway's law. We are looking at how do we structure organizations and what that means for the systems that result. If we have the right kind of ownership of services within a team, with the right kind of focus, then what you get are these loosely coupled, independent, if you will, services. And you've got a strong sense of ownership. Many companies who have adopted something like microservices have a model where they don't have a separate support and maintenance organization anymore. The people who write the services are the ones that are carrying the pagers. And so obviously they have a vested interest in making sure that that code is as solid as possible because they don't want to be disturbed on a Saturday night. they are responsible, and that sense of ownership carries forward into their stewardship of these services. Appropriate coupling. One of the ways that we look at evolutionary architecture is what is the right level of coupling, balancing off the performance and the complexities and all of that. Contracts. One of the ways that we allow different parts of a system to evolve independently is by me knowing what assumption you're making about my service. Some of the best enterprise architects I've ever known are the ones who carry around in their head all of those funky little connections between systems that everybody always forgets about. The things that this system needs this other system to do that really doesn't make any sense, but they know that those things exist. By using contracts and these automated contract testing, test tools, we can start to document the assumption that different parts of our system are making on each other. And that way, I can give you my tests, and then I can go and do whatever it is I want. Safe in the knowledge that when that test breaks, that's your trigger for a conversation. You call me up and said, okay, we've got to talk, because I just broke one of your assumptions. Some change that I'm making is going to require a change on your part. Until that happens, I don't need to know a thing about what you're doing. You don't need to know a thing about what I'm doing. We can go completely independently. And so this level of documentation in a test, which therefore we know it's going to be kept up to date, gives us that flexibility and that safety net to be able to do these things independently. And so that's why these contracts between microservices are so important as well. And of course, I'm from ThoughtWorks, this is a talk, therefore I have to talk about testability. But one of the interesting things that we have found is if you do nothing else in terms of your architecture, if you concentrate on how easy it is to test your system, you will end up with a cleaner architecture. And if you think about it, that makes sense. Something that is easy to test has a well-defined description. You don't have to say, I need to test this and this and this and this and this. You have something, even if it's at a very high level, like an end-to-end test, you have something that succinctly describes the behavior. Things are easy to test when they are visible, when you've got the right knobs to turn, you've got nice separation. And in general, we have found that just paying attention at whatever level you're talking about, whether it be code level or system level, thinking about testing gives you a better architecture. And so this focus on how easy it is to test these individual services, how easy it is to compose them, how easy it is to then understand what is the end-to-end behavior expectation with all of these different services. Think about testability, and you will end up with a better architecture. And generally speaking, an architecture that is much easier to change because of the way the boundaries are defined. So then, what role does continuous delivery have to play in all of this? Well, first and foremost, microservices are a whole lot harder to run in production than a monolith. And it's going to be a much bigger burden on your operations department. There are more things to deploy, there are more things to monitor, there are more things to go wrong, you've got more databases, so you've got more things to back up separately, and all of those things that you have to think of. You've multiplied them. And so it's going to increase the burden on operations. More things to deploy, more things to monitor, and that monitoring and the failure recovery, how you bring a system back up, is much more complicated. You've got many more permutations of how things fail in a microservices architecture. I put inadvisable on the slide. Basically, I believe it is borderline irresponsible, if not outright irresponsible, to try a microservices architecture if you don't have a strong DevOps culture. If you've got a throw over the wall mentality between your development team and your operations team, this is going to be a disaster. There's so many things that need to be done properly, that need to be understood. And if you don't have this strong DevOps culture, your ops team is going to end up hating you. It's also inadvisable without a lot of the rigors that come with continuous delivery. When we start looking at infrastructure automation, we want to be able to reliably recreate environments. When you have all of these different error possibilities, error scenarios, your ability to debug is critical. And if you don't really know for sure what version is running in production, how in the world are you going to debug? And so the rigors that come with continuous delivery are also critical to overcoming some of the issues or some of the implications of using microservices. So infrastructure automation, deployment automation, and of course, test automation. You want to be able to understand how these different services are interacting with each other. You have a much more complicated test landscape. Even the happy path is a whole lot more complicated, let alone thinking about all of the different scenarios, than just having one big monolith. So you want to think about test automation as well. So how do I get started? As I said, what we're seeing is if you start out thinking that you're going to build microservices, and you do that right out of the gate, chances are you're going to get your service boundaries wrong, and you're going to get yourself in trouble. And so it makes more sense to really start building a monolith. Build it well, build it with good separation, with a good understanding of what clean code looks like, but start with a monolith. And then as you progress, as you start to understand more about the domain concepts, you can start to break some of those things out. But starting out building a microservice architecture, unless you are very, very familiar with the domain, is probably a mistake. And it's certainly not what I would do the first time you're ever building a microservices system. You don't want to start that greenfield. And that does seem counterintuitive, because if we're starting with a monolith, we've got all of that coupling, all of those assumptions that are being made. But the complications that come from starting with a microservices architecture are such that people just seem to get it wrong more often than not. And so it's safer to get to a particular level of comfort with the domain and with some of the implementation challenges you're going to run into with that particular technology in that particular domain before you start to separate it out. Which is, of course, to say, no, it is not a silver bullet. We are seeing a lot of success with microservices architectures, but there are issues to consider. Now, all of these things that I've talked about, eventual consistency and having to deal with it, these distributed failure scenarios, this is not something that we don't know how to do. We've been doing things like this for a long time. We do know how to manage a process, a business process that spans over multiple processes and what happens if one thing fails. We know how to do communication. We know how to do all of these different things. It's not that we don't know how to do it. It's just that it is more complicated out of the box. However, done right, what you then have is the ability to make fairly radical changes to particular parts of your overall system. You can completely redesign some particular aspect of your business and be safe in the knowledge that as long as you haven't violated any of those contract tests, the rest of the system does not have to change. You have enforced boundaries which will make it much easier for you to change your business process, introduce new functionality, introduce new validations, deal with additional regulatory requirements, all of those different things, because those are the things that are changing more rapidly. As soon as one person on a social media site puts out some new feature, now all of a sudden all the websites have to have this new feature. Customer expectations are changing that rapidly. Regulatory environment is changing more rapidly. Business model lifetimes are getting shorter, let alone all the thinking that people are now starting to do about security and data privacy and what am I really doing and how secure is the information that my bank is keeping. So all of these different things are putting this pressure on us to be able to change our systems more rapidly, and microservices is an approach to that, but it does come with a cost. Come on. So, to learn more, one more, there we go. So there's a book on building microservices. This actually started out as a book about continuous delivery. And I think one of the interesting things about microservices, if you think about it, this is the first major architectural paradigm that has come along since continuous delivery started being something that was talked about in the industry. And I think you can see that what we're talking about from the perspective of microservices is not something you would really want to do unless you had something like continuous delivery. So I don't think it's at all a coincidence that this kind of architectural style has not come along before now. Because even in the old SOA days, you didn't have the number of services. The granularity was very different. That was, in fact, one of the problems that we had because those services were too big. And then, of course, continue the continuous delivery book, because both of these things are important together. I will reiterate, your operations department will hate you if you do this when you have a separate operations department that you're throwing code over the wall to. You need to involve them in this because their processes of how they monitor things, how they do error recovery and such, are going to be very different. So, thank you very much.